All right, hello again, pre-calculus people. So today we're going to talk about the law of cosines. In the previous video, which I'll link to at the end of this one, we talked about the law of sines. And then in that, all we did was the single situation where you're given two angles and any one side of a triangle. There is another application of the law of sines, but I'm going to do a separate video on that one. Today's law of cosines, though. So, and there's two situations where we use the law of cosines. We can either be given all three sides of a triangle, which so we have to find all three angles, or we find two sides in the included angle, and I'll talk about about that little bit of detail here in a minute. So here is the law of cosines. Now, the one thing I was gonna like, wait a minute, there's three of them. What's going on here? No, there's only one, but because it's all the same formula, and we're going to talk about a couple patterns in here. Now, the one thing you might notice is if you cover up like the last part of that, that's basically the Pythagorean theorem. And because what this is, what the law of cosines really is, it is a stronger version of the Pythagorean theorem, because we know the Pythagorean theorem only allows us to solve right triangles, right? But the law of cosines now allows us to solve any triangle, whether it has an obtuse angle or all acute angles or whatever. So this is really a stronger version um, or a general version of the Pythagorean theorem. The other thing I want to talk about pattern-wise is notice the reason there's three of them is it depends on what you're finding and what you have given. Like if you want to find angle A, the only option is to use the top one. Right? If you want to find angle C, the only option is to use the bottom one. And then the same thing when we get to the two sides and one angle case, you'll see that there's only one option to use to find that third missing side. Okay, so and also remember, so like the A and the A, B and B, C and C on the ends, that's how you can kind of keep the different versions separate. And then on the inside, BC, BC, AC, AC, AB, AB. Okay, so do you have to memorize it? No. Is it memorizable? Yes. I'm kind of go from there. So I've got two examples. I've got one example with all three sides given, so you find all three angles. And then the second example will be basically the side angle side case, if you remember that from geometry, the two sides and the included angle. So let's hop right into it here. So given A, B, and C of 5, 12, and 8, and listen, you don't have to draw a triangle, but I like drawing a triangle just to give myself a visual of what's going on. Doesn't have to be accurate, but we'll do it that way. So that's 5, there's 12, and 8. Remember, the A, B, and C pairs are always opposite their corresponding angles. So the first thing I'm going to do is I'm going to find angle A. You can find it in any order. I like doing things alphabetically. Okay, so if I'm finding angle A, again, I have to use the top one because that's the only thing that has angle A. I know all my little A, little B, little C. So I'm going to plug everything in, and then we're going to do some algebra to isolate the A, and then we're going to use a calculator. Okay, so here we go. So A squared equals 12 squared plus 8 squared minus 2 times 12 times 8 times cosine of A. And again, I'm just plugging numbers in based on the formula. You're also going to notice I'm not going to figure out what these are. I know that's 25, 144, and so on. I'm not going to bother. I'm going to let the calculator do all the work for me at the end at one time. Okay? Now to isolate this, I'm going to do this one in two steps, but I'm going to also kind of go over the pattern with you. So if you remember back in your algebra days, I want to get this A by itself, right? So what I'm going to start by doing is I'm going to get the cosine A by itself. So think to yourself, what would I have to do? Well, the first thing, I'd have to subtract the 12 squared and the 8 squared. So I would hand on to both sides, of course. So we got 5 squared minus 12 squared minus 8 squared would be equal to negative 2 times 12 times 8 cosine A. And then keep on thinking of isolating, getting this thing by itself. So now I've got to divide by that whole quantity. Remember, this is just a number, right? It's just a coefficient. So I'm going to divide by the whole thing. So once cosine A by itself, and I'm going to bring this on the other side just to make it easier to write. So cosine A is going to be equal to, all of this stuff stays on the top, 5 squared minus 12 squared minus 8 squared. And then I'm going to divide by that everything that's basically attached to the cosine. So minus 2 times 12 times 8. Now the last bit we got to do here, of course, we don't want cosine A, we want actual A. Okay, so if you remember back a couple weeks ago when you talk about inverse trig functions, whenever you're finding an angle, if you want to undo a cosine or sine or anything else for that matter, it's just the inverse cosine. So the way we write that, it'll be the cosine inverse, equal to minus 1, and then this whole thing. And then we're going to put that whole thing into the calculator. Now, whether you're using an Inspire or Desmos or whatever, the first thing, make sure that your calculator settings is in degrees. You got to make sure that's in there first. Okay. Once that's there, then we just start typing this in. In the interest of time, to keep the video a little bit shorter, I'm not going to go back and forth to Desmos to type this in because I've worked the answers out in advance. But make sure that again, when you type it in, especially in Desmos or an Inspire for that matter, it should look exactly the way you have it written on your paper. Okay, and when you type that in, you should get about 17.61. And I'm going to just round that to the second decimal place. So 17.61 degrees. Okay, now once I have angle A, now I just repeat the process to find angle B. So I'm going to do this just in a different color just to kind of keep things separated. So now if I'm finding angle B, again, now I use that middle equation because that's the only one that has angle B. So I'm going to plug in all my side values and then do the same thing. So I'll start with B squared equals A squared plus C squared minus 2 times A times C cosine of B. Now this one, I did this in a couple different steps here. This time I'm going to do it just one time, and I'm going to hope that you see what I'm doing. Remember, my goal is to get B by itself. So here we go. So B is equal to, the first thing we're doing is subtracting. So the top of your fraction, and also remember, we have to do the cosine inverse, right? So cosine inverse on the outside, parentheses, make a fraction. Top of the fraction is going to be all your squared values. So the thing you start with, so my 12 is going to be on the outside, and then subtracting the other 2. And then on the bottom, it's just going to be that whole coefficient, so the minus 2 and the 5 and the 8. And then you type that into Desmos just the way it looks, and you should get 133.43. And now our hard work is done, right? Because now to find angle C, all I got to do now is just subtract. Because I've got 2 of the angles, and we've known for a couple of years now, several years, that the sum of the angles always equals 180. So C is just going to be 180 minus 1761 minus 133.43, and that'll come out to be 28.96. Okay, so that is using the law of cosines to find your missing angles. Remember, pick the formula you're going to use depending on the angle you're trying to find, set everything up, and then just isolate that B. It's always that same process, cosine inverse, the squares on top, and then the coefficient of cosine on the bottom. So let's move on now to the second situation where you use the law of cosines. I call it the side angle side case from geometry, the SAS, because notice this is what we call two sides in the included angle. And if I sketch this triangle that I'm given, so if I give side A, side B, and angle C, if I just sketch what that looks like, so if that's 15 for side A, that's 18 for side B, and then my angle C is 38. The included side, what that means, the included angle, what that means is the two sides you're given basically make the angle that you're given. What we'll see in the next, when I do the other law of sines video, called the ambiguous case, is going to be two sides and the not included angle. So we'll cover that in a different video. So what we've got to do in this case, we have to find the third side first. Okay, because we can't do anything else until we have all three sides. So we do that, and again, we got to find side C. So come up here and we're like, okay, well, I have to use the bottom one because, again, that's the only angle that I do know, so that's the only way that I can find side C. So I'm going to plug all that stuff in. So it'll be C squared, because I don't know it. And again, you can do this in one step too, but I'm going to kind of write the whole thing out. So C squared equals A squared plus B squared minus 2 times A times B cosine of C, but I know what that is. It's 38. Okay, so this is the easy one because there's no solving going on here. All I got to do is undo the squares, so it's just square root the whole thing. So C is equal to the square root of exactly what I just wrote. And then when you put that in Desmos or your calculator, again, just make sure you're in degrees, you end up getting 11.11 when if you kind of go to the second decimal point there. So that is your third side. And then to start finding the angles, remember, we only got to find one angle with the law of cosine because the third angle we can just find by subtracting. So I'm going to find angle A next. And again, this is just like we did on example 1. So if I'm finding angle A, I use that first law of cosines equation. So start with A squared. So the equations will set up like 15 squared, and then 18 squared, and C squared. And again, C is a decimal. Who cares? Because the calculator is going to do the work. So 11.11 squared minus 2 times 18 times 11.11 cosine of A. And remember my pattern. If I'm looking for A, I know I've got to undo the cosine, so cosine inverse. Parentheses fraction. I'm going to put all the squares on top, starting with the first one, and then subtracting the other two. And then the bottom, all your coefficients, so -2, 18, and 11.11. And the one thing you notice too, I don't think I said this in the first example, but the two squares you're subtracting, the 18 and the 11.11 in this case, same numbers in the bottom. And that's always going to happen also. So if you stick that into Desmos, you end up getting 56.21. And now our hard work is done. To find angle B, we just subtract. So we got 180 minus 56.21 minus 38, because I was given the 38 in the problem. Oops. So B is going to be equal to 85.79. So that is the law of cosines. So So as always, if you have any questions, feel free to send a message. Come into tutoring if you're one of my students. And again, I will have a link to the Law of Cosines video that will pop up right about now. Until next time, stay safe.